Welcome to the IDEX Fire Safety Group S-Key Service and Troubleshooting Guide Part 1. Part 1 is an overview of the Class 1 S-Key electrical system. Part 2 will cover network operation, S-Key Pro 2 software and system troubleshooting. The definition of multiplexing is to send multiple signals over a single communication line. For example, telephone, internet, and cable TV signals can all be sent over a single cable system. S-Key is a complete electrical system made up of a combination of hardware and software. It is widely used on ambulances and fire trucks, and is also used on military vehicles, buses, RVs, aviation, rail car movers and occasionally on boats. The S-Key system was first developed in 1995 and has a proven track record of reliability. Builders like to use the S-Key system because it is easy to customize vehicle features and functions. Labor savings can be realized during installation, because there are fewer wires, splices and connections. The I/O nodes are sealed, but Class 1 recommends mounting nodes with connectors facing downward, when possible. This way any water that gets in the connectors can drain back out. Unused connector pins should also be plugged to keep them waterproof. The system has built-in diagnostic features, and further troubleshooting can be accomplished using the S-Key Pro 2 software. S-Key stands for Electrical System that requires a key card and is a multiplexing system. S-Key uses a shielded, 2 or 3 wire, communication cable. The signals are differential mode, monitoring the difference in voltage between the 2 wires. The cable is twisted pair, which helps eliminate noise from outside sources. The network uses J1939 protocol, meaning that messages are sent continually. Each complete message contains several bits of information. The S-Key network utilizes the J1939 CAN bus. The definition of CAN is Controller Area Network. S-Key is custom configured by the OEM. The target vehicles are designed and built around a CAN bus network, and containing a variable number of S-Key modules that, to simplify, control inputs E, G, switches and outputs E, G, power. At the core of each vehicle network is a Universal System Manager USM and USM2 or Supernode or Supernode 2 that implements the configuration created using S-Key Pro software. A modem, a USB interface module or USB cable is used to upload or download configurations and diagnose and monitor system activity. The power of S-Key lies in the ability to control the state of any output by designing logical equations based on the state of inputs and outputs configured in the system. For example, power to a water pump on a fire truck may be controlled by numerous factors beyond a simple switch. The output to activate the pump may require the pump switch to be turned on but may also require the engine high idle sensor and the parking brake sensor to both be on as well. This is a simple example, however, the logic equations are infinitely extensible and allow any number of logic layers necessary to properly represent the desired functions. The result is that a complex or even impossible wiring harness is eliminated by using a network of simple devices and a core controller configured using the S-Key Pro 2 software. In a conventional, relay-based electrical system, there is a lot of point-to-point wiring. There are many connections between switches and the relay box, and many more wires coming from the relay box out to all the devices. A multiplex system allows the use of electrical zones. Nodes can be placed throughout the vehicle, resulting in shorter wires runs to devices. Only the J1939 communication cable, power and ground are needed for the nodes to operate. These fewer connections result in higher reliability. The S-Key system is a master-slave network. In a master-slave network, each node has its own address setting. The Universal System Manager USM contains the database or configuration that details how all inputs and outputs relate. Each node communicates with the USM to pass its input states and receive output state commands. If one node were to stop working, the remaining nodes will continue to operate. There can be up to 32 nodes in the network. The S-Key nodes feature solid-state outputs, which have no moving parts. The outputs can be set to flash, and the standard flash patterns are 75 and 150 flashes per minute. The flash patterns can be synchronized throughout the network, and there is an AB pattern for wigwag flashing. Some outputs can provide a variable output level using pulse width modulation, or PWM. This is used for features like light dimming and fan speed control. The nodes also feature on-board diagnostics so outputs can report shorts and opens occur. Outputs can be programmed with on and off delays or sequencing, which is used to delay on and off functions from 1/10 of a second to 60 minutes on some outputs. Sequencing is used to reduce the heavy load on the battery system when warning lights are enabled. Load management means outputs can be shed when node voltage gets low. Each input and output node monitors its own voltage and reports it in levels from 0 to 7. Level 0 means the output shedding never occurs. Level 7 is below 12.8 volts. Level 6 is 12.7 volts, Level 5 is 12.5 volts. Level 4 is 12.3 volts, Level 3 is 12.1 volts, Level 2 is 11.9 volts, and Level 1 is 11.5 volts. The S-key system will work on either 12 or 24 volt vehicles. The load shed level voltages are slightly more than double on the 24 volt vehicles. Auto throttle is a feature that can be used to increase engine RPM when the voltage gets low. It is very important to include interlocks, such as park brake and neutral, to prevent a runaway situation when auto throttle becomes active. Inputs are programmable, meaning they can be configured to activate with battery positive or ground. Here are some details about Class 1 S-key system components. The USM2, part number 122-116, is a solid-state module that controls and monitors the S-key network database. The module is referred to as the USM2 or Universal System Manager 2. In the S-key network, the USM2 is responsible for evaluating and controlling the database's multiplex equations, monitoring faults, diagnostics, and controlling electrical load management functions. All S-key network traffic is routed through the USM or a supernode to the appropriate S-key modules. The USM2 has 6 polarity selectable inputs and 5 polarity selectable outputs rated at 500 mA. It has a few integrated components: a vehicle data recorder with seatbelt warning, a data logger, J1939 gateway, load manager, programming utilities, and HID USB connection. The VDR with seatbelt warning is configured within the S-key Pro 2 software. Up to 20 seats and belts inputs can be configured in the system. The inputs can be used on any device with inputs within your database. The VDR extraction is done with the VDR software. The VDR software can be downloaded from the Class 1 website www.firmware.class1.com at no additional cost. The VDR saved data is retrieved and viewed using the VDR Viewer 2 data management software. The USM2 USB port must be connected to the computer running the VDR Viewer 2 data management software. The USM2 contains all the standard features of an S-key data logger. Capture events and faults. Time set and transmission. Upload and download of events and header data. The J1939 gateway connects to the chassis J1939 to read specific messages from the engine and transmission. This allows the chassis message reception and S-key inputs and outputs association. Examples are stop and check engine lamp, coolant temperature, engine oil pressure, neutral, etc. You can reference the USM2 datasheet for a list of J1939 messages used, and how they are associated with the S-key inputs and outputs. The USM2 USB port allows database transfers and diagnostics with the S-key Professional 2 software. Connect the USM2 to a computer running the S-key Pro 2 software with harness part number 513-00011. The SuperNode 2 part number 119890 consolidates functions of multiple S-key modules to reduce node count and simplify addressing, and is well suited for applications where a centralized node location is required. It has an integrated USM and is responsible for evaluating and controlling the database's multiplex equations, monitoring faults, diagnostics, and controlling electrical load management functions. All S-key network traffic is routed through the USM, internal to the SuperNode, to the appropriate S-key modules. The SuperNode 2 has 18 positive outputs rated at 13 amps, 6 negative outputs rated at 2 amps and 24 polarity selectable digital inputs. The SuperNode 2 contains the USM, VDR seatbelt warning, data logger, J1939 gateway, load manager, programming utilities and HID USB connection. The climate control system within the SuperNode 2 is designed for use with a climate control display like the standalone climate display part number 120179 or a climate control enabled Ultra View display. It contains the outputs for AC clutch, heat valve and the fan PWM speed. The internal-external temperature is connected in an analog to CAN module as a thermistor input. There is a 180 amp overall current limit. With extensive use of LED lights in modern emergency vehicles, it is unusual to approach that limit. Pulse width modulation can be utilized on outputs 10 through 16 and 75-150 Hz flash for outputs 0 through 17. The programming utilities offer another feature for Flash that can be used with any device output within the database. The SuperNode 2 USB port allows database transfers and diagnostics with the S-Key Professional software. Connect the SuperNode 2 to a computer running the S-Key Pro software with USB cable part number 629 to 00025. There is a new version of the 8x16 node. Its new part number is 610 to 00058. It has 8 polarity selectable digital inputs and 16 outputs. 14 of the outputs are positive rated at 13 amps, and 2 ground outputs rated at 2 amps. All outputs are PWM and flash capable. The 8x16 PDM has the integrated capability to flash outputs for use with flashing lights, wigwag lights, etc. The 8x16 PDM use 2 addresses in order to accommodate the required number of output memory spaces. The outputs can be controlled on at reduced power by activating the output's associated PWM control in the standard output memory space. The input polarity is controlled by extended output memory spaces 24 through 31. Refer to the output memory space table in the PDM datasheet for flash, PWM and polarity selection. The address is configured with inputs 0 and 1 that will determine the module address on power up. Once the unit has been powered, and an address has been selected, the module will maintain that address during that power cycle. The address inputs have 3 states: float, high, and low. The chart will display the address selection based on the states of the inputs. The OEM is responsible for limiting each Deutsch connector to a maximum of 70 amps of output current and to ensure that no more than 150 amps is permitted through the power supply cable. Combining multiple outputs to increase load carrying capability is not recommended due to current balancing issues which may cause overcurrent conditions. The power distribution module part number 610 to 0034 responds to commands to activate its physical outputs and reports the state of its inputs back to the network. The module has 8 outputs rated at 7.5 amps, of which 4 of the outputs can be polarity selectable or configured as polarity selectable inputs. The polarity of outputs 4 to 7 are selected by setting the output polarity shunts and the input/output dip switches, located inside of the case, to the desired positions. The polarity of each input is selected by setting the input/output and polarity dip switches, located inside of the case, to the desired positions. The PDM has the integrated capability to flash outputs by activating the output's associated flash control in the standard output memory space. For use with flashing lights, wigwag lights, etc. The outputs can be controlled on at reduced power by activating the output's associated PWM control in the standard output memory space. Refer to the output memory space table in the PDM datasheet for flash and PWM control. The address is configured by rotating the address switch, located inside of the case, to the desired value, 0 to 15. Use an address selection tool, or a number 1 Phillips screwdriver, to set the position of the switch to the desired address. The device type is selected by setting the selection switch, located inside of the case, to the desired position. The switch is labeled Dev ID and is directly related to the device type. When the switch is down, it is a device type 1, PDM. When the switch is up, it is a device type 4, IM. The power distribution module part number 610 to 0035 responds to commands to activate its physical outputs and reports the state of its inputs back to the network. The module has 12 outputs rated at 6.5 amps, of which 4 of the outputs can be polarity selectable or configured as polarity selectable inputs. The module also has 4 multifunction inputs. Inputs 4 to 7 that can be configured to be used as a digital, analog input with a range of 0 to 5 volts, 0 to 30, 4 to 20 milliamps, thermistor and frequency. The polarity of outputs 8 to 11 are selected by setting the output polarity shunts and the input/output dip switches, located inside of the case, to the desired positions. The polarity of each input is selected by setting the input/output and polarity dip switches, located inside of the case, to the desired positions. The PDM has the integrated capability to flash outputs by activating the output's associated flash control in the standard output memory space. For use with flashing lights, wigwag lights, etc. The outputs can be controlled on at reduced power by activating the output's associated PWM control in the standard output memory space. Refer to the output memory space table in the PDM datasheet for flash and PWM control. The address is configured by rotating the address switch, located inside of the case, to the desired value 0 to 15. Use an address selection tool or a number 1 Phillips screwdriver to set the position of the switch to the desired address. The device type is selected by the selection switch located inside of the case to the desired position. The switch is labeled Dev ID and is directly related to the device type. When the switch is down, it is a device type 1 power distribution module. When the switch is up, it is a device type 4 input-output module. The high current PDM, part number 610-00046, is a module with 8 high current positive outputs rated at 30 amps, 4 selectable polarity inputs and 4 MFI multifunction inputs. This allows 4 inputs to be polarity selectable inputs and 4 inputs that have analog capability: digital 0 to 5 volt, 0 to 30 volt, 4 to 20 milliamp, thermistor and frequency. Input 7 also can be reconfigured to a voltage reference output that is selectable between 5 volt and 9 volt. The HC to PDM has the integrated capability to flash outputs by activating the output's associated flash control in the standard output memory space. For use with flashing lights, wigwag lights, etc. The outputs can be controlled on at reduced power by activating the output's associated PWM control in the standard output memory space. The high current PDM has 8 selectable polarity inputs, positive or ground. The state of the inputs is reported in the standard input memory space. The default polarity of the inputs is positive, but they may be configured by entering a special password using the external buttons. The address is configured by entering a specific password using the external buttons. Refer to the output memory space table and list of passwords in the HC PDM datasheet for flash, PWM, address and polarity selection. The high density PDM, part number 12727, is a module with 20 positive outputs rated at 13 amps, 1 ground output rated at 3 amps, 10 selectable polarity inputs and 10 MFI multifunction inputs. This allows 10 inputs to be polarity selectable inputs and the possibility of configuring up to 10 inputs to have analog capability of digital, 0 to 5 volt, 0 to 30 volt, 4 to 20 milliamps, thermistor and frequency. The ground polarity output can be reconfigured to a voltage reference output that is selectable between 5 volt and 9 volt. The HD PDM has the integrated capability to flash outputs by activating the output's associated flash control in the standard output memory space. For use with flashing lights, wigwag lights, etc. The outputs can be controlled on at reduced power by activating the output's associated PWM control in the standard output memory space. The HD PDM has 10 selectable polarity inputs, positive or ground. The default polarity of the inputs is positive, but they can be individually configured by entering a special password using the external buttons. The HD PDM has 10 inputs that can be individually configured as MFI using as password. The address is configured by entering a specific password using the external buttons. Refer to the output memory space table and list of passwords in the HD PDM datasheet for flash, PWM, address and polarity selection. The input, output and analog module part number 610-00030 has 18 polarity selectable, 3 polarity selectable outputs and 1 analog input of either 0 to 5 volt or 4 to 20 milliamps. The module can be configured to use 18 digital inputs that can be configured for either positive or ground input polarity. Inputs 0 to 15 are always available to the user. Inputs 16 and 17 are shared with outputs 0 and 1 and the user must select which ones to use. The polarity of each input is selected by setting the input polarity selection switches and the input/output selection jumpers located inside of the case to the desired positions. The switches are labeled in 0 through IN17 and are directly related to the physical inputs. Each input can be placed in the positive, down position or ground, up position. The module has 1 analog input that can be configured for either a 0 to 5 volt input or a 4 to 20 milliamp input. The module can also be configured to supply a positive 5 volt or 9 volt reference and a ground reference. If the references are configured, the module will no longer be able to use input 16 and 17 or output 0 and 1. The mode of the analog input is selected by setting the selection switch and the input/output selection jumpers, located inside of the case, to the desired positions. The selection switch is labeled analog and is directly related to the analog input mode. The analog input can be placed in a 0 to 5 volt mode or a 4 to 20 milliamperes mode. When the switch is down, it is in the 0 to 5 volt mode. When the switch is up, it is in the 4 to 20 milliamperes mode. The Smart Touch Switch Panel is a fully customizable switch solution for utilization within a Class 1 S-Key or Weldon VMUX multiplex network. The Smart Touch Switch allows control and indication of outputs configured within the network database. The Smart Touch Switch Panel is available in 6 layouts: 4 switches, part number 610-00061-004, 5 switches, part number 610-00061-005, 8 switches, part number 610-00061-008, 10 switches Ultra View Surround, part number 610-00061-080, 12 switches, part number 610-00061-012, and 16 switches, part number 610-00061-016. The Smart Touch switches can be configured for individual switch types and paired switch types, upper and lower. Each switch has its own LED ring which is used for backlighting, white and indications, red, green and blue. The leftmost 4 switch LED rings also serve a dual purpose as a diagnostic indicator. The Smart Touch has 6 configurable switch type functions: momentary, bistable, toggle upper switch, toggle lower switch, toggle exclusive and a dimmer. The Smart Touch is recognized by the S-Key Professional software as an SPS module by default but may be configured via password as an input-output module. The Smart Touch address may be configured to any valid S-Key address by entering a password. The Smart Rocker switch allows control and indication of outputs configured within the network database. The Smart Rocker switch panel is available in 2 layouts: 4 switches, part number 610-00081-004, and 6 switches, part number 610-00081-006. The Smart Rocker switch panel is a fully customizable switch solution for utilization within a Class 1 S-Key or Weldon VMUX multiplex network. The Smart Rocker switches can be configured for individual switch types and paired switch types, combined upper and lower. Each switch has its own LED which is used for backlighting and indications. The leftmost 4 switch LEDs also serve a dual purpose as a diagnostic indicator. The Smart Rocker has 6 configurable switch type functions: momentary, bistable, toggle upper switch, toggle lower switch, toggle exclusive and a dimmer. The Smart Rocker is recognized by the S-Key Professional software as an SPS module by default but may be configured via password as an input-output module. The Smart Rocker address may be configured to any valid S-Key address by entering a password. The S-Key Information Center provides status and diagnostic control functions for a vehicle equipped with a Class 1 S-Key multiplex system. The Information Center has a display with 4 lines, 20 characters on each line and 6 buttons. 3 of the buttons have dedicated usage: escape, scroll up and scroll down. The 3 buttons below the display are soft buttons whose function is dictated by the displayed text above the associated button. The Information Center initializes to the main screen and shows the custom greeting during a power-on cycle. The System menu allows entry into the diagnostic screens, utility menu, and information pages. Enter the S-Key System menu by pressing the middle soft button directly below the text menu. The time and temperature are shown, if available, on the 4th line of the display, time to the left of the word menu and temperature to the right of menu. The Information Center has the capability to display up to 32 warning and information messages on the main screen. The System menu is the base menu screen and allows access to the Diagnostic menu, System Utilities menu, and the Information screen. The Diagnostic menu allows viewing of the interlock states, Load Management screen, and allows access to the Developers menu. The System Utilities menu allows the configuration of the system date, system time, and unit of measure. The Information screen allows viewing of the message data configured for the Information Center. The Information Center is called a display within the S-Key Professional software. The OEM creates the message data, which typically consists of warranty information, maintenance schedules, contact information, etc. The Developers menu allows viewing, control, and modification of S-Key networks inputs and outputs. The System Outputs menu allows access to the multiplex equation, load management association, and vocation interlocks of each network output. The S-Key Diagnostics menu allows access to the Output Diagnostic screen, Input Diagnostic screen, Module Status screen, Database Statistics screen, Database Information screen, Current S-Key faults, and Historical S-Key faults. The Output and Inputs Diagnostic screen allows viewing and temporary control of S-Key network outputs and inputs. This screen is very useful for diagnosing database or hardware issues. The module status screen allows viewing of the modules and their status in the S-Key network, including the module version. The current and historical S-Key faults screen allows viewing of any of the S-Key system faults, modules offline, communication errors, overcurrent conditions, etc. The Ultra View displays come in several screen sizes: 7-inch diagonal, UV 780, 7-inch diagonal, touch only, UV 800, 5-inch diagonal, UV 500, 11-inch diagonal, UV 1100, 12-inch diagonal, UV 1200, 4.5-inch diagonal, UV 450, 3.8-inch diagonal, UV 380. The displays are touchscreen capable, store up to 12 different languages and configured by the OEM using the PowerVision software. The Ultra View displays are used in S-Key and VMUX systems. Diagnostics is available for S-Key and VMUX systems. The displays are viewable in direct sunlight, sealed IP67 and operating temperatures of -40 degrees to +85 degrees Celsius. NTSC/PAL video inputs ranging from 2 to 4 depending on the type and size of the display. There are 2 J1939 CAN network ports with selectable baud rates. The H-Bridge module is an S-Key node designed to allow a designer the ability to utilize the product within the S-Key electrical system network. The module responds to commands to activate its physical outputs, and reports the state of its inputs back to the network. The module has 5 outputs, of which 2 of the outputs can be polarity selectable. The module also has 3 polarity selectable inputs, of which 1 can be configured as an analog or frequency input. The module having the ability to also work as a network-controlled H-Bridge module. The H-Bridge address may be configured to any valid S-Key address by entering a password. The dual analog to CAN with accelerometer is designed to monitor 2 analog inputs and transmit the information on the CAN bus. It can allow the user to select how the analog inputs and reference voltages are configured. The user can select each channel to read a 0 to 5 volt signal, 0 to 30 volt signal, battery monitor, 4 to 20 milliamp signal, thermistor signal, temperature signal, and 1 channel can be set to read a frequency. The user can select if the channel reference voltage is enabled or disabled. If the reference is enabled, it can be selected to deliver a 5 volt or a 9 volt output. The module also is an accelerometer that can be used as an inclinometer or impact sensor that reads G-forces in 2-axis and transmit the information to the S-Key network. There's also 1 polarity selectable input and 1 ground 250 milliamp output. The vehicle data recorder and seatbelt input module are used to monitor seat positions and to record NFPA required data, which is emergency master, park brake, service brake, ABS events, vehicle speed, engine RPM, throttle percentage, and seat compliance for up to 20 seat positions. The Supernode contains the vehicle data recorder and seatbelt inputs that can be configured to any input or output module in the system. Data is saved on a second-by-second basis, for up to 100 engine hours. When the memory is full, the VDR will begin to overwrite the oldest data. The VDR doubles as a CAN gateway, allowing communication between the S-Key network and CAN-based networks, such as J1939. The vehicle data recorder and occupant restraint indicator can be used on non-S-Key vehicles. The VDR comes programmed from the factory. Each seatbelt node will allow 10 seats to be configured. The VDR allows 2 seatbelt nodes which can be configured by addressing the node. The VDR has a USB interface for configuration and data extraction. The USB adapter cable is just a standard printer cable which can be purchased locally. In order to extract data, or set up the VDR configuration, you must enter the password, which from the factory is 12345678. This password can be changed or reset. A 2 to 5 second debounce can be configured on the seat's occupancy signal to help prevent nuisance noncompliance faults. If an occupant bounces off the seat switch on a rough road, no fault will be detected if the seat switch signal is received again within debounce set time period. The vehicle data software is available at www.firmware.class1.com. The occupant restraint indicator is a display that shows status of 12 seat positions, designated as seats 1 through 12. It connects directly into the CAN network on the VDR or the S-Key network, if it is installed on an Ultra View. A no LED indicator means off, or no seat or belt detected. Green means compliant, indicating that both the seat and belt signals were received in the correct order. Red is non-compliant, which can be seated and not belted, belted and not seated, or that the signals were received out of order. The seat occupancy signal must always be seen before then belt signal, for compliant indication to occur. A 2 to 5 second debounce timer is used on the seat's occupancy signal, to help prevent nuisance noncompliance faults. If an occupant bounces off the seat switch on a rough road, no fault will be detected if the seat switch signal is received again within setting of the debounce timer. There is a debounce override if the seat and belt stay connected throughout the debounce. An audible alarm will occur for any non-compliant seat when park brake is released. Seat status can also be shown on an ultra-view display, eliminating the need for an occupant restraint indicator display, on S-key-equipped vehicles. Other components include the air temperature sensor that can be tied into an analog input or climate control module. The USB to CAN interface is used to connect a computer loaded with a Class 1 S-key professional software, to the J1939 CAN bus of an S-key multiplexed vehicle. The USB to CAN interface allows uploading and downloading of S-key databases and real-time diagnostics. The S-key climate control module is an S-key node that controls a vehicle's air conditioning clutch, heating valve, and fan motor speed with high current digital outputs based upon received J1939 CAN commands from a supported S-key control device. The climate control module has dedicated inputs-outputs for 2 analog temperature sensors, to determine internal and external vehicle temperatures. The climate control module has 2 modes of operation, automatic and manual. There can be up to 32 nodes in the network in an S-key network, and each node has an address and device name, such as SuperNode 1, Power 2, etc. The address of each node is set to 0 from factory, so they must be addressed on the bench or outside of the vehicle or before they are installed. The USM or SuperNode can be reprogrammed in network. There should not be 2 devices with the same address and device type. This problem is usually caused when vehicles have 2 or more of the same devices and forget to change the address. The S-key system is a J1939 CAN-based network and can operate at high speed, 250 kbaud. There is a J1939 CAN-based network for connecting to a chassis J1939 CAN network and can operate at 250 k or 500 kbaud. It's very important that terminating resistors are used on an S-key network. The network uses Deutsch 3-way splitters, and the 3-pin connectors that plug into the splitters have either green, orange, or blue wedge locks that are keyed. To keep the network layout organized, ideally the wires with the blue wedge locks will be connected to the trunk line that goes from splitter to splitter, and the green or orange connector from each splitter will drop off to the nodes. Class 1 recommends the use of J1939 compliant network cable that has a twisted pair or shielded. The S-key network can be plugged directly into a CAN-based network using a USB to CAN communication device, SuperNode 2 USB or USM2, USB to communicate with the network. Each network should have a 3-pin network tap connector to allow easy connection of the USB to CAN device for diagnostics and downloading. On the S-key network, the shield wire should be grounded in the node using the supplied position in the connector. The shield is there to help prevent outside noise sources from affecting the COM wires. It should be connected on pin C of all the splitters. The S-key system is a variable-based system. There are 2 types of variables, digital or analog. Each variable or port name is assigned to the port address and device decided by the designer. You can name the port name with a meaningful name, such as left seam light switch, reverse lights. Inputs and output can be named to have their own meaningful name. A digital signal is simply on or off, and an analog signal is for variable data, such as temperature, pressure or amperage. The analog signal will be used when an ultra view is included in the network to display items such as temperature, pressure or amperage. The SuperNode utility module can read specific CAN messages from the engine or transmission such as miles per hour, and this correlates to the program port used in the database logic. All S-key modules contain diagnostic LEDs to indicate module status. Red indicates module power, amber indicates a connection to the CAN bus, green indicates communication is active in the module. The SuperNode has diagnostic LEDs for inputs and outputs as well as power and communication indicators. The power red status LED indicates the system voltage or power to the node. If on steady, there's power to the node. If off, there's no power to the node. The bus yellow status LED indicates power to the output driver bus bar. If on steady, there's power to the output driver bus bar. If off, there's no power to the output driver bus bar. Note that not all modules have an output bus connection, in which case the LED is connected to the internal power of the module. The COM green status LED indicates the CAN communication to the node. If off, no CAN communications connection to the module. If flashing at 1 Hz, CAN communications OK, but device not recognized or configured for the network. If flashing at 5 Hz, CAN communications OK, but device has address conflict with another module on the network or shorted. If steady, CAN communications OK, module active. The address is selected by rotating the address switch to the desired value, 0 to 15. Use an address selection tool, or a number 1 Phillips screwdriver, to set the position of the switch to the desired address. Address 14 cannot be used if the device type is the default PDM because this device type and address combination is reserved for the SKey USMUs. To address the HCPDM or HDPDM, use the green square and red circle buttons to enter passwords. Each button press will show either a 1 or a 0 on the display to indicate the button pressed, 1 for the green square button and 0 for the red circle button. Each password button press must occur within 4 seconds of the last button press, otherwise the attempted password is cleared. The high current or high density PDM's address can be set to any of the valid SKey addresses 0 through 15. The password to set the address consists of 8 button presses. The root password is the first 4 button presses, and the remaining 4 button presses indicate the desired address in binary coded decimal. Address 14 cannot be used if the device type is the default PDM because this device type and address combination is reserved for the SKey USMUs. To enter a password, a magnetic switch must activate the 2 magnetic switches in a specific order. Switch 0 will indicate a 0 from the password list and switch 1 will indicate a 1 from the password list. When the switch is activated by a magnet, the address LEDs will turn on to indicate the switch was activated. Switch 0 will activate add1 and switch 1 will activate all the add LEDs. If a password is entered incorrectly or a password is entered that is not in the password list, the add LEDs will alternate on and off to indicate an invalid password was entered. This concludes Part 1, the overview of the Class 1 SKey electrical system.